Most people board an airplane without ever thinking about the engines. They sit outside the window like oversized metal cylinders suspended beneath the wings. Steady, predictable, almost permanent. And because modern airliners look so familiar now, most passengers assume the engines were always meant to be there. But they weren't. In fact, one of the biggest engineering questions in aviation history was this: where should the engines actually go? Because airplane engines aren't attached beneath the wings by accident. That position solved multiple problems at once: balance, aerodynamics, fuel efficiency, maintenance, even the structural survival of the aircraft itself. And early engineers spent decades discovering those lessons through experiments, limitations, and uncomfortable surprises along the way. In the earliest years of aviation, airplanes looked nothing like modern jets. Many aircraft had engines mounted directly in front of the pilot. Others placed them above the wings. Some even mounted them behind the aircraft entirely in pusher configurations. And during the 1930s and 1940s, as airplanes became larger and faster, engineers were still debating the best possible layout. At the time, propeller aircraft dominated aviation. Their engines were relatively small, lighter, and behaved very differently from modern jet engines. But after World War II, aviation changed rapidly. Jet engines produced enormous thrust compared to older piston engines, but they also introduced completely new engineering problems. They were heavier, hotter, more fuel-hungry, and they affected airflow around the aircraft in ways engineers were still trying to fully understand. At first, many early jet aircraft placed engines inside the fuselage or near the tail. For a while, that actually seemed logical. Keeping engines close to the aircraft body reduced drag and gave airplanes a sleek appearance. Aircraft like the British de Havilland Comet used engines integrated into the wings themselves because engineers believed cleaner shapes would improve performance.
But hidden problems slowly began appearing. Maintenance became difficult. Internal engine placement consumed valuable cabin and cargo space. And as jet technology evolved, engines kept becoming larger and heavier. That created serious structural challenges. One of the biggest breakthroughs came during the rise of large commercial jet aircraft in the 1950s, especially through engineers working on aircraft like the Boeing 707. And engineers eventually discovered something fascinating. Placing heavy engines beneath the wings could actually help the wing structure itself. At first, that sounds backwards. Why would hanging thousands of pounds beneath a wing make the airplane stronger? The answer involves how airplane wings behave during flight. As an aircraft moves through the air, lift pushes the wings upward. That upward force creates enormous bending stress near where the wing connects to the fuselage. But engines suspended beneath the wings create downward counterweight forces. In a strange way, the engines partially help balance the wing's structural loads. Instead of the wing carrying all lifting stress alone, the engine weight offsets part of the bending force.
And that realization became incredibly important as commercial aircraft grew larger, especially for long-distance travel. But structural balance was only part of the story. Aerodynamics mattered too. Modern jet engines require enormous amounts of smooth, uninterrupted airflow. And the space beneath the wings turned out to provide surprisingly clean airflow conditions. Far enough away from the fuselage to reduce turbulence, high enough above the ground for safety, and positioned close to the aircraft's center of gravity for stability. That balance improved fuel efficiency as well. And fuel efficiency became one of the most important economic battles in aviation history. Even tiny aerodynamic improvements can save airlines enormous amounts of fuel over thousands of flights. That's why modern engine placement is studied with incredible precision. Wind tunnel testing, computer airflow simulations, structural vibration analysis. Entire engineering teams spend years optimizing positions measured down to inches.
Because moving an engine slightly forward or slightly higher can change airflow behavior across the entire aircraft. But there was another major advantage passengers rarely think about: maintenance. Jet engines require constant inspection and servicing, and engines mounted beneath the wings are dramatically easier for ground crews to access. Technicians can inspect systems without dismantling large sections of the aircraft body. Repairs become faster, maintenance costs decrease, airplanes spend less time grounded. For commercial aviation, that matters enormously. A grounded airplane costs money every hour it cannot fly. So easier engine access quietly became one of the biggest practical advantages of underwing placement. And there was still one more hidden benefit: safety. As jet engines evolved, engineers needed ways to isolate engine-related vibration, heat, and mechanical stress away from passengers and sensitive aircraft systems. Mounting engines beneath the wings created separation from the main fuselage structure. That reduced noise transmission into the cabin and simplified certain structural protections.
Of course, engineers still face challenges. As engines became larger during the late 20th century, some aircraft designs struggled with ground clearance. The famous Boeing 737 originally sat relatively low to the ground because early jet engines were much smaller. But newer, high-bypass turbofan engines became enormous in diameter. Engineers had to redesign engine housings and mounting positions carefully to fit beneath the wings while maintaining proper runway clearance. That's why some modern airliner engines appear slightly flattened underneath instead of perfectly circular. A small visual detail hiding a very large engineering compromise. And perhaps that's the fascinating part of aviation design. Modern airplanes may look smooth and effortless from the outside, but nearly every visible shape exists because engineers were solving multiple invisible problems simultaneously: weight, airflow, fuel consumption, structural stress, maintenance, safety, economics, all balancing against one another at 35,000 feet.
The next time you sit beside an airplane window before takeoff, look carefully at the engine beneath the wing. That position wasn't chosen simply because it looked symmetrical. It was the result of decades of aerodynamic discoveries, structural engineering lessons, maintenance realities, and engineering compromises hidden inside modern aviation. And suspended beneath those wings is one of the most carefully calculated placements in engineering history. If you enjoy hidden engineering stories, invisible design decisions, and the forgotten logic shaping the modern world, welcome to Rivet and Decisions.